All right, thanks everyone. Appreciate you looking in on this video. Here's what we were talking about today. We've got Studio One open, which is a digital audio workstation. I've created a track, it's in record mode and it's recording. And then I've dragged over two different plugins, a Pro EQ, which is what we're looking at now, and a spectrum meter, which is a really fine meter as to the information that's coming in on this channel. Gives us kind of a visual representation of the audio signal that's coming through. We have a similar signal on this EQ, which is really nice. It'll show us what the effect visually we're having on this sound as we kind of play with it. So what we're going to do first, and we're talking about tone today, is we're going to kind of replicate some of the problems that happen, whether it's on a film set or in a podcast recording or in a live show, that make the sound, the tone of a sound, just kind of undesirable. Like first of all, how do we notice what these problems are? How do we recognize it? And then what do we do to fix it? So first of all, we're going to look at this low frequency EQ knob. And I'm going to pull it all the way down and then just really cut out all this low end information. And as I start to raise it, you're going to hear what's happening is that we're going to start losing some of that low end, some of the nice warm tone, the warmth of the quality. And as I keep going and keep going, really, when we get up to about 1K or so, all we're going to be hearing is this kind of high-end sibilant information. And what this is replicating is if you're off-axis on a mic, as we've talked about, or if you are just too far away from a microphone, really, the further away you get, the more low-end information you're going to be missing out on. That's really captured by the proximity of the microphone. You really want to be, with a shotgun mic within a few feet, or ideally within a few inches or under a foot. With a vocal mic, like a handheld dynamic vocal microphone, you really want to be a couple inches away, or else you're losing all this low-end information that's really hard to listen to. So let's undo that so that you can actually listen to this without, hating yourself. Or hating me for that matter, and kind of do the same thing with the high end. What we're going to do, same thing, we've got it all the way up at 20K, we've got a shelf, and we're just going to pull it down on the gain, and then now we're going to grab that frequency and pull it down. Now what happens when you are just have a bad mic placement, or you're recording in a less ideal situation or with not as great equipment, you're going to start losing out on some of that high-end information. Again, we're down, let's put it right again at about 1K. You're losing all of that high-end information, which really makes it unintelligible and hard to listen to. So let's undo that again. That's obviously drastic and really over-exaggerated examples of what happens here, but I do that so that you can hear really well what it sounds like. So what does this all mean? What do we want to do here? The ideal tone, you're hearing this is a flat signal right now. I haven't done anything to the sound. I don't have any compression or EQ or anything on this sound, and it sounds decent. It's not the best sounding recording in the world. It's not the best thing you've ever heard, but it's passable and it works. It sounds like a podcast or a screencast or something like that. Pretty industry standard sound. Now let's look at what that looks like. Most of the tonal information from a male or female voice is going to happen between, you can see this frequency readout. Most of it is happening at the low end, about 90 hertz, and on the high end, around 1K. Most of that information is happening right here. And you can see that it's coming in pretty flat. If we put that bar, that green bar right at about 72, that's kind of where everything is averaging. Peaks at about 63, 62, but on average, we're right on this kind of plane right here, this axis of 70, 72 decibels on this meter. And then what you have is kind of a nice taper from about 2K all the way down to 20K. So that, you're not getting way too much sibilance. You're not getting a ton of low end. It's just this kind of flat signal, frequency-wise, all the way down. And then it's got this nice even taper all the way down to 20K, which is really kind of an ideal and what we're used to frequency response, kind of, a tone. This is the tone that we're used to hearing, and this is pretty much what we're hearing if we're just talking to one another. This is what our ears are picking up. So what happens if you kind of take out that low end again or take out that high end, then all of a sudden you've got this huge gap between the information between 1K and 100 hertz, and then the huge dip, and then very little low end stuff. We're missing out on that nice curve. It's just pretty much gone at that point. So we don't want that. If our ideal curve is kind of flat and then a nice taper, anything that's going to change that is going to make it sound less good or even bad. What happens if we do the same thing with that signal, but instead of cutting it out, we boost that signal? Kind of, exaggerating what happened over here when we kind of boosted or lowered the low end stuff. Now what's happening is we have way too much high end information, not a ton of, the good stuff, and then very little low end information. Again, it throws off our curve, and we have no longer a nice flat curve here that tapers off. We've got a curve that then has a huge bump, and then, it's almost flat sometimes as I talk and use more of my S's. It's almost flat instead of having a nice curve, and that nice decay or that taper is happening way higher at 10K instead of down at 2K. So as you can hear, it's not great. It's not pleasant to listen to. It's not good. These are some of the issues you want to look at as you're recording a podcast or recording instruments or doing live sound. You want to get to the point where you can do this by ear. You can just hear those things and then know how to fix them. But in the interim, you can really use tools like this, like these kind of third octave RTAs or these FFT readouts that really show you what's going on so that you can start dialing in that nice curve that we're looking for and get the sound that's going to help you retain your audience and not turn them away because it doesn't sound good. You're not going to be hurting people's ears in a live show. All these things are not stuff we want to do. So thanks for watching. Hopefully that's helpful, and we'll see you next time.